Welcome back to my YouTube channel, subscribers, and if you're not a subscriber, please subscribe right now. My name is David Banda, the Universal Data Boy, or you might as well call me the A+ Ambassador. That's what they used to call me when I was doing natural sciences. And that's how I start my videos in most of my tutorial NS videos, which I'm going to talk about later. Anyway, I'm student engineer David Banda, and to dive right into what we're going to be talking about today, which is one of the most requested videos that I've had, where people have been asking me how I made it through NS, the best techniques and strategies that you can use when you want to do natural sciences, non-quotas, or whatever. And also, if you have got any questions, any video requests that you want me to make, you can drop it in the comment section. You can also send me a WhatsApp on my number that I'm going to share on the screen, and then we can keep on interacting just like that. I share study tips on my status. I also provide mentorship for those that come to university. For those that need academic mentorship, I do offer mentorship for free. Basically, natural sciences are the four sciences, which is physics, chemistry, biology, and math. Just to give you a background story about myself, I'm a boy who went to university to pursue engineering, and then after going to university and seeing how, because to do engineering and any science in most Zambian universities, you first have to do the natural sciences first, and after you do the natural sciences, non-quota or whatever you call them, that's when you're going to be able to pursue your program. So when I started, it was very, very hard for me, and on several occasions I did try to quit. I remember when I did my first quiz, which was chemistry. I always share this story. First quiz, chemistry, I write, knowing that okay, I've done my best, and I had a 2 out of 10 in the quiz. Oh! And that's the moment I was like, this thing is not for me. And several occasions you would find that sometimes a lecturer would do, especially physics, would like solve a question on the board. After he rubs the question, gives you the exact same question, same numbers and everything, and tell you to start doing it, and you'd still fail to do it. At first it seemed impossible. It was bleak, everything was blurred, and coming to this point is what I'm going to share in some of my videos. And when starting, I really wish I had watched a video like this one. It could have really helped me to go through my NS. Long story short, because of the passion that I had for engineering, and because of the persistence, the techniques, and methods that I had employed to make sure I go through my NS, I did manage to go through my NS, and not just with any grades. I managed to go, for my first semester, I had 3 A's and 1 B+, and for my second semester, I had an A, 3 B+, and a B. Oh my God! Wow! The A+ started to kick in when I started engineering, but even then, in NS, I was referred to as the Universal Data Boy and the A+ Ambassador, which was a name that was given to me by some of my friends. Not wasting much of your time, we're going to dive right into it. I'm going to go course by course, and after I do the courses, I'm going to give an overall techniques that you can employ, and the do's and don'ts. For those who don't know, for all universities in the country right now, if you're going to be doing a science program, you have to do a natural sciences first, a science degree program, that is. Even people who are doing computer science, even people who are doing mathematics and statistics, even people who are doing pharmacy, even people who are doing engineering like me, and even people who are doing any other courses that are related to science, mostly. And I think for all, I've not seen one in which they don't. For all, you have to do your natural sciences first. Even School of Medicine, you have to do your natural sciences. Firstly, you might say it's unfair, but it's the system. I'll give you an example of myself. I'm doing engineering, but I know how a lac operand works. I know how the cell cycle operates. I know how an enzyme operates. I know a lot of things in biology that I had to know when I was doing my natural sciences. So even people who are doing medicine will complain that they do the physics that not even actually apply once they start doing their actual programs. But it's NS, and you have to go through it. Okay. So let me start with the first NS course, which is biology. Most people call it molecules and cells. Most people call it different names. But basically, it is biology, and you'll be able to say this is biology. So for biology, the first tactic that personally I had was watching animations. So you see, biology is made up of, it's basically processes. It's processes that happen in the human body, processes that we're able to see ourselves. So it's mostly hard to visualize, and if you've been doing academics for a while, you're going to realize that it's easier to learn something once you're able to visualize it. So for biology, what you're going to be mostly interested in are animations on YouTube. So if, let's say, you're going to be looking at transcription or how DNA replication works, you have to view an animation that is going to show you all the processes, the micro processes that are going to be happening in the human body. That way it's going to be able to stick in your brain. And then when you start writing an essay on, let's say, transcription or DNA replication, you're going to be able to write it based on that animation, because you're going to, in your brain, you're going to be picturing all the processes that were happening when you are watching that video, rather than you just reading a whole paragraph, a whole essay, and trying to write it. It will be very, very hard for you, especially that you have to remember the words that were written in the essay. Mostly that's what our brain will try to do. But if you employ this tactic where you first watch animations that are going to show you the processes, it's going to be very, very easy for you. I do mentorship. I mentor a lot of people who are in university, and people have testified to this technique. For biology, it really works wonders. The second technique that you want to employ is you're going to use mnemonics. So mnemonics really help you, and what mnemonics are phrases that you're going to use to help you memorize things. A good example that I'm going to use in biology is in the cell cycle, in mitosis. There is what is called the processes. We used to use a mnemonic that was called PMAT. So PMAT stood for prophase, metaphase, anaphase, and telophase. So this is how they align themselves. So if a question came to say describe mitosis, it will be very, very easy for you, because the first thing that you're going to write on your paper, of course not on your answer sheet but on your question paper, is PMAT. And then it's going to be easy for you to say you start with prophase, metaphase, anaphase, and telophase, and even if you've forgotten what basically happens in the processes, for the fact that you've written them straight ahead and how they are, and you've aligned them in the correct way, you stand a very, very high chance to get most of the marks in the question. And then it's going to be easier for you to just try to elaborate or try to explain what these processes are, because by virtue of you knowing how they are aligned, it's easy for you to know that after this starts, this follows, after this starts, this follows, after this starts, this follows. So that's the very second thing that I'm going to advise you to use when you're going to be working with biology, which is mnemonics. Mnemonics are a very, very good tool, and they really helped me in the exam. Lastly, what's going to help you is the technique that I called the read, write, write, read, write. So it's read, write, write, read, write. So the first read is you read the material. After you read the material, you write what you are reading. In this case, the reading I'm referring to is studying itself. So you read, then you write what you are reading. Then after you write what you are reading, of course you're going to leave out some things. So what you're going to do is you're going to write those things that you left out. And then now you're going to read the material with the things that you wrote and the things that you left out. So now it's a full material. And then now you're going to read both of these. Then after you read, you're going to write again. And now when you write, you're going to write everything that you have to write, and nothing will be forgotten. And then that way it's going to stick. Whatever essay that's going to come, if you use this method, definitely you're going to be able to write it when it comes in your exam. You're going to be able to understand it. You're going to be able to memorize. And the second one that I'm going to go to is math. Well, others were going to call it methods of math, mathematical methods, principles of math, introduction to math, but it's math. And mostly it's in NS, it's going to be the same thing over and over again. Whatever university that you're going to go to, they basically have the same topics, the same way they bring questions, and the same way that they lecture. The very first thing is math is different from biology, and you should shy away from the notion of memorizing, and you must make sure you understand the material. So that's one. The second thing that you have to do is you have to make sure you make your brain flexible enough to understand things that might not make sense to you at that particular point. An example that I'll give is from grade 1 to grade 12. We've all been taught the square root of a negative number does not exist. But then when you come to university, now you're taught to say the square root of -1 is I. So you have to have your brain being able to understand this I. I is basically an imaginary number, a number that doesn't exist, but we imagine it exists. So if your brain is not flexible enough to understand these things, you're going to be left in the past, and the whole of the topic is going to be very, very hard for you, because you can't grasp the concept of having a negative in a square root. It's like the time when we just started school, grade 1, grade 2, I think up to grade 4, when you are asked to say, let's say 1 minus 3. For the fact that 3 is bigger than 1, we are going to say it can't. And then when we came to grade 5, we were told that the answer is -2. So it's going to be, if at that particular point when you are going to grade 5 you didn't grasp the concept of having a negative number where numbers would go even to the negative, or a situation where you subtract a smaller number from a bigger one, which is hard for people to grasp even after they finish their grade 12. It's going to be hard for you. So basically math is in the same way, except the skills are broadened, the skills are enhanced. The tactics that you have to employ: one, you have to make sure you do as many practice problems as possible, do as many past papers, tests and the like. And then the problem that people make is they employ this tactic but they don't employ it well. What do I mean? So someone is going to get practice problems, is going to answer the practice problems, but doesn't know whether what they have answered is correct or not. So make sure when you're going to be handling practice problems, there are solutions aside. And then you don't go to the solutions first. You don't rush to the solution. You make sure you try as much as possible. You try your best to answer the questions. And then when it's hard for you, or when you arrive to the final answer, you try to compare what you have and what's in the solution manual. If the solution manual is not available, you can go to your tutor, you can go to your friends, you can go to your lecturer. And then there are a lot of applications, there are a lot of softwares, there are a lot of websites on Google that answer math. So you can just punch in a math question. We have got things like photo math, where you just capture a question and the answer will be brought for you. We have things like Chat GPT, where you can type in a math question, it will give you the answer and the procedure, and then you're going to compare. After you try, you're going to compare to that one. So that's the first strategy. Make sure you do your practice problems. And then number 3, after you write a test, after you write a quiz, after you write, of course not an exam, but test, quizzes, any assignment, any assessments or assignments that you're going to have, once they are marked and you are given back the answer scripts. Of course, some universities don't give the answer scripts, but you can try to answer separately and try to see what answer you got correct and what answer you got wrong. So when you get your answer script, you see where you went wrong and where you went right. And then you have to review the things that you did wrong, and then try to make sure you do them all right this time around. Because if you miss out a concept in test 1, if a similar concept comes, maybe even in a different topic, but a similar concept, you're going to get it wrong. If the same concept comes in the exam, you're going to get it wrong, because math is conceptual. It deals with concepts. And so if you have a problem with a concept, it's going to be hard for you until you handle that concept. I'll give you an example of negative, positive. Most people have got a lot of problems. When a question comes, they'll be able to solve it very nice and neat. But immediately we have got negatives and positives, it becomes hard for them to answer the question. So what you have to do is you have to make sure you handle it. Whenever you write a paper, you see where you are wrong, and then not only where you are wrong, but even the questions that you got right, you should try to review them, because you know, as time goes on, you can easily forget. And then you should also have simulations. So animations for biology, simulations for math. So you should have simulations that show you, especially for graphs, like once you change a certain variable, how does the other variable change? Once you change something else, how is something affected? So there are various simulations. There's one that's called PHET simulations. I think there's a website. I'm going to put it in the description box, and then you're going to be able to see it. You can just punch in some numbers, some variables, and it's going to show you. That way you're going to have a good understanding of the concepts of math. And then you can also use YouTube videos. I do some videos that you can check the link in the description that are going to be able to help you. But basically, you should watch a lot of videos. I also recommend some channels that you can watch. For example, JG the Organic Tutor. Even other YouTube channels like Khan Academy, Professor Dave Explains, and there's this guy. He really helped me when I was doing my math in first year. He's Dr. Chreso, something like that. I'm going to share the link for his YouTube channel in the description box as well. Third one, chemistry. So how we are going to handle chemistry is the very first thing is you have to understand the basics. For math and biology, you have to understand the basics as well, but even without the basics, you can still make it. But for chemistry, once you miss the basics, chemistry and physics, you miss the basics, you're gone. The second thing that you also have to understand is the more concept. You have to make sure you acquaint yourself with this topic, because many of the topics in chemistry are encompassed upon this. And once you miss the basic principles of the more concept, it's going to be very, very hard for you to handle chemistry problems or anything. Coming to my third point, which are problems, you should handle as many practice problems as possible. That's going to make you understand a lot of chemical reactions and many ways in which elements on the periodic table actually function. And then coming to my third point again, you must understand the periodic table. You must understand the periodic table. Not memorizing what's on the periodic table, because the periodic table will be provided for you in most of the exams, most of the papers, most of the tests. You have to understand the periodic table. What is the atomic mass? What does it mean when a certain element is in a certain period? What does it mean when a certain element is in a certain row? How is it going to react with others? And for chemistry, you might as well also want to utilize mnemonics. And an example of a mnemonic that I use is a mnemonic that we use for light particles. For example, we used to use a mnemonic that was called Roig Beef. Yeah, we used to call it Roig Beef. So which is the light particles of the spectrum. For example, like the rainbow. Yeah, so it's red, orange, yellow, red, green, blue, indigo, and violet. So it's just by knowing Roig Beef, you know all the colors of the rainbow and how they are arranged. Thus, it makes it easy for you to make your way around. It makes it easy for you to be able to memorize things that you'll be unable to memorize without Roig Beef. Trust me, I can't tell you the colors of the rainbow and how they are arranged. And sometimes it's important. You might be asked this in a question in an exam to say, what are the colors of the light spectrum? How are they arranged? You have to know Roig Beef for you to understand these things, because you might misplace one or two. For chemistry, just as biology, you also want to utilize the animations. That's how different chemicals come together to form up things. You also want to utilize simulations that you can find when you mix various chemicals. What colors are you going to have? What scent is going to come out? How are they going to be able to mix together? Are they going to be endothermic or exothermic and stuff? I want to utilize rigid material, and a book that I'll prescribe mostly for NS, especially in Zambia, is Zumda, a book called Zumda. Any edition can be able to help. I'm going to post a link of the book in the description if I'm going to be able to find it on the internet. And then also other books that I'm going to once I just find them on my laptop, I'm going to share the links or the pictures or anything. Lastly, for chemistry, you also want to know units. You want to know how to use units and make sure you don't forget units, because when you use the wrong units, everything is distorted. For example, for water, the density of water is 1 gram per centimeter cubic, and then it's also, when you're going to be using kgs, that's kilograms per meter cubic, is going to be 1000. So now if you're going to have the question, you have to see what units does the question have. Units that you also want to look out for are units like pressure. As an example, it has, I think most of the units, it has millimeters of mercury, it has bars, it has pascals, it has a lot of other units. So you want to know what unit to use when and how to convert from one unit to another. And you, coming to my third point even, you want to know how to use conversion factors. That's converting from one unit to another, because questions will come in different units and you have to use other units. And then sometimes you will know some constants in other units and you have to convert them to other units for you to be able to work them out. And you also want to, on the same units, you also want to understand units so much that you can even solve questions using units. I'll give you an example. Density, coming back to density. Density is kilogram per centimeter, kilogram per meter cubic rather. So just by the units, you can know that to find density, it's kilogram per is like over. So kilogram per centimeter cubic. So kilogram per meter cubic, sorry. So you know that to find density, you have to divide the mass, which is kilograms, by the volume, which is meters cubic. So just by the units themselves, you can easily understand the formula from the units, and you can easily derive a formula from the units. And then from the units themselves, you can come from one place to another. For example, if you want to find the mass of water, you have the volume. All you have to do is, and I don't really want to dive deep in the math, but basically all you have to do is you have to multiply the density by the volume so that the kilograms can cancel out, so that the meters cubic can cancel out. When the meter cubic cancels out, you're going to remain with the mass itself. So sometimes you can just, even from the units themselves, I'll share a video in which I had elaborated how to use units. and dimension analysis in trying to work out problems. Even just in the units themselves, you can know a lot. If you're given a constant with units, you're going to know that you have to use this constant in this way. And units are very, very important in chemistry. Another topic that I'll give an example of, chemical kinetics. So in chemical kinetics, okay, there are a lot involved, but basically I want to go to the segment that deals with rates of reactions. So just by looking at the units of the constant, you can know the order of the reaction. For example, if the constant is moles per second, you're going to know that you're dealing with zero order. If the constant is per second, just per second, you're going to know that you're dealing with a first order reaction. And if it's per moles second, you're going to know that you're dealing with a second order reaction. So units are very, very, very important. They are very, very vital. Once you understand them, chemistry will be easy. Once I understood the units, I was basically one step away from an A. And now coming to the last one, I think this is the subject that most people are scared of during NS. And basically it's one of the subjects that I did enjoy myself. It's one of the courses that I would feel, you know, when I'm studying, I would feel to say, okay, this is the stuff. Of course, I'm not saying it's easy, but it was one of my favorites because it's, you know, physics in university is applied physics. So it's physics that you do not just learn the concepts. You're able to apply them, you're able to see how they are working, and you're able to understand how various things operate. I'm going to share a video just right here so that you see and appreciate how much physics really is important to us in a bit. But first, I want to share with you what is really going to help you in physics. So in physics, you want to be able to utilize units, just as I said in the chemistry itself. Also, you want to handle as many practice problems as possible. The more you know how to handle problems, the better it is going to be for you. And then you also have to understand the basic principles, just like chemistry itself, especially Newton's laws of motion. Once you understand Newton's laws of motion, I think for physics, you are halfway there. Not just knowing them to say Newton's first law of motion states this, second law of motion states that, and third one states that. You have to understand. Once you understand, you're going to be able to apply the three laws of motion in various points in your physics learning. You want to be able to know how to use a free body diagram, how to make a free body diagram, how to draw a free body diagram. It's going to be very, very helpful for you because basically whenever you have a physics problem, you must first visualize it, and after you visualize it, you're going to be able to handle it swiftly and smoothly. And these are one of the things that I had to learn as I was progressing in my first semester. And once I was able to hone these skills, physics became not very easy, but it became easier for me than it was in the first place. You also want to utilize books like Gayankoli, books like Sewe. You also want to utilize videos on YouTube. But basically, for me, what has really helped me in physics is the book Sewe and Gayankoli. I used to study these two books, and basically they teach you as if you've not even yet written your grade 12. It's like you're just coming from grade 7 and then you are reading this book because they simplify everything. And what they do in these books is they teach you the concepts. After the concepts, they give you questions in which you apply the same concepts that you are just from studying, and that's where the concept will stick because you're able to know the concept. And then secondly, how you can apply. So utilizing YouTube channels like Professor Dave, the Organic Chemistry Tutor. He also does physics, by the way. He does physics, math. That's the JJ I've been talking about. And lastly, the most important channel that you want to subscribe to is the Universal Data Boy. Make sure to this channel, if you're going to be doing physics, you subscribe to this channel. For people who have got questions, especially physics, because physics is my favorite. When you're going to be doing engineering, physics and math have to be your second love. They have to be something that you like. They have to be something that you wake up to, something that you sleep to, something that you dream. And so yeah, if you have got any questions in physics, I share my number. In fact, I'm going to share my number in this video as well, so that you can see it. I share my number on the YouTube channel, David Banda, the Universal Data Boy, so that if people have got questions, they ask the questions. And sometimes I do make a video about the questions they ask, so that in case other people have got the same questions, they can just refer to the same video, or I'll reply in just a voice note or just typing to say how you handle this question in this way, and this way. Most importantly for physics, what I'll urge you is to go for concepts. go for understanding the concepts. Each topic has a particular concept that it wants you to understand. So go for the concept. Do not just dive right into the questions, which is the mistake many people do. Because realizing that most of the questions that come in the test and the exams are from story sheets, they just dive direct to the story sheets. So what happens is you memorize how to answer the question, but you don't know the concepts that are working in the question. So what you want to do is to sit down, study the particular topic, and after you study the particular topic, after you understand the concepts in the particular topic, you're going to use those concepts to answer the questions. That way you're not going to only memorize the questions, but you're going to know how to handle them. In case they are twisted in a certain kind of way, in case a different question is brought with the same concept, you're still going to be able to handle it. So if you employ some of these techniques, they're going to be able to help you a lot, because they've helped me based on experience. And if I had watched a video like this one when I was starting my natural sciences, I couldn't have been on the verge of quitting, and I could have had better grades than I had. Of course, I had one of the best. I was among the best in my intake, but I feel if I watched something like this, I could have done more than I actually did. So make sure you do that. And then what you also have to understand is different people have got different personalities and how they perceive study. One man's trash is another person's treasure. So a technique that's going to work for you is not going to work for another person. So you also have to establish what is going to be working for you. If a technique is not working, change it immediately. That's all for now. Subscribe to this channel, but for me, it's bye-bye.